4 astronauts are about to fly farther from Earth than any human being has traveled in over 50 years. And they won't even land. What NASA learns from this single 10-day loop around the moon could determine whether humanity ever builds a permanent presence beyond our planet. Artemis II is the mission that puts human lives on the line aboard hardware that has only flown once before, uncrewed. The crew of 4 will strap into the Orion spacecraft atop the most powerful rocket ever to reach orbit, the Space Launch System, and arc around the far side of the moon at distances exceeding 370,000 kilometers from home. Every system, life support, navigation, communication, faces its first real human test. This is the story of what Artemis II actually involves, why it matters, and the razor-thin margins that separate triumph from disaster. Artemis launched on November 16, 2022, sending an uncrewed Orion capsule on a 25.5-day journey around the moon and back. It was a flawless shakedown flight. The heat shield survived re-entry at roughly 40,000 kilometers per hour, and the spacecraft splashed down in the Pacific Ocean on December 11th. But robotic success means nothing until humans are inside. Artemis II exists specifically to validate every crew-rated system under real deep space conditions. The environmental control and life support system that scrubs carbon dioxide and manages humidity. The Orion crew displays and controls, the manual piloting capability, and the communication latency that stretches to several seconds near the moon. NASA needs to confirm that 4 human beings can survive and operate effectively at lunar distance before committing to a surface landing on Artemis III. It is, in every sense, the dress rehearsal with the highest possible stakes. Commander Reed Wiseman is a Navy test pilot and veteran of a 165-day stay on the International Space Station in 2014. Pilot Victor Glover, also a Navy aviator, spent 167 days in orbit during SpaceX Crew 1 in 2020 and 2021. He will become the first Black astronaut to fly beyond low Earth orbit. Mission specialist Christina Koch holds the record for the longest single spaceflight by a woman at 328 consecutive days aboard the ISS, logged between 2019 and 2020. Canadian Space Agency astronaut Jeremy Hansen, a former CF-18 fighter pilot selected in 2009, rounds out the crew as the first non-American to fly on a lunar mission. Together, they bring more than 660 cumulative days of spaceflight experience. Each was chosen not just for skill, but for the ability to troubleshoot novel systems in an environment where no rescue mission is possible. The rocket beneath them is the Space Launch System Block 1, standing 98 meters tall and generating 39.1 meganewtons of thrust at liftoff, roughly 15% more than the Saturn V. Its core stage is powered by 4 RS-25 engines, the same design that flew on the Space Shuttle, but upgraded with new controllers and nozzles. Flanking the core are 2 5-segment solid rocket boosters, each producing about 16 meganewtons of thrust and burning for approximately 126 seconds before separation. The interim cryogenic propulsion stage, powered by a single RL-10 engine, handles the trans-lunar injection burn that sends Orion toward the moon. SLS is an expendable vehicle. Every launch consumes the entire rocket. At an estimated cost of over $2.2 billion per flight, there is no margin for error. Every component must perform exactly once and perfectly. Artemis II follows a free return trajectory, a flight path engineered so that lunar gravity itself bends the spacecraft back toward Earth without requiring a major engine burn. After launch from Kennedy Space Center's Pad 39B, Orion will spend about a day in a high Earth orbit, during which the crew tests spacecraft systems. The ICPS then fires to inject Orion onto a translunar coast, lasting roughly 4 days. The spacecraft will swing behind the far side of the moon, passing within approximately 8,900 kilometers of the lunar surface. At that point, the crew will be more than 370,000 kilometers from Earth, farther than any human has traveled since Apollo 17 in December 1972. Communication blackout behind the moon lasts around 20 minutes. The entire mission is planned to last approximately 10 days, with splashdown again in the Pacific Ocean. Orion's environmental control and life support system must keep 4 people alive in a habitable volume of just 9 cubic meters, roughly the interior of a large SUV. The system manages oxygen generation, carbon dioxide removal using lithium hydroxide canisters, trace contaminant control, humidity regulation, and thermal management. In deep space, exterior temperatures swing from about 120 degrees Celsius in direct sunlight to minus 150 degrees in shadow, and the active thermal control system must handle both extremes continuously. Water recovery from humidity condensate supplements the onboard supply. During Artemis I, these systems ran autonomously. Now, every parameter will be measured against the metabolic output of a real crew, breathing, sweating, and generating heat. NASA engineers have flagged the heat shield's thermal protection as a particular area of scrutiny after post-flight inspection of the Artemis I capsule revealed unexpected charring patterns in the ablative material. Deep space crewed flight carries risks that low Earth orbit does not. Beyond the Van Allen radiation belts, the crew will be exposed to galactic cosmic rays and potential solar particle events with no planetary magnetic field for shielding. Orion's radiation storm shelter, located in the central area of the crew module, uses onboard supplies and equipment as supplementary shielding. Mission planners monitor solar activity forecasts in real time and can adjust timelines if a coronal mass ejection threatens the flight path. The abort options are also far more limited. During translunar injection, a failure would require the crew to rely on the service module engine for a corrective burn. The free return trajectory itself is a critical safety feature. If the service module fails entirely after TLI, the moon's gravity alone can send the crew home, much as it did for Apollo 13 in April 1970. If Artemis II succeeds, Artemis III becomes the mission to return humans to the lunar surface for the first time since 1972. That mission will dock Orion with SpaceX's Starship human landing system in lunar orbit, transfer 2 crew members to the lander, and descend to the South Polar region near Shackleton Crater, where permanently shadowed craters may hold billions of kilograms of water ice. Artemis IV would follow with the first modules of the Lunar Gateway, a small space station in a near rectilinear halo orbit around the moon, serving as a staging point for sustained exploration. The broader Artemis program envisions a permanent lunar outpost by the 2030s, generating knowledge and technology needed for crewed missions to Mars. Everything in that chain depends on what 4 astronauts learn inside that 9 cubic meter capsule on the way to the moon and back.